Hello, how you doing? So, for today's interactive presentation, we are going to be doing some yeast and hydrogen peroxide, ZD kind of rocketry of sorts. So, let's make sure everything's good before we jump in. Okay, awesome. So for this, we're gonna need a mason jar, some hydrogen peroxide, yeast, teaspoon, a piece of ZD, a mason jar with a lid with a little hole in it for the chemicals to shoot out, and a match. Okay, so let's get started. And we're gonna do this kind of slowly because it's a little dangerous slash nerve-wracking. You gotta be careful. So this is just an estimation, honestly, how much you should be putting into this. I'd say like 1/8 maybe. Don't want to use so much hydrogen peroxide that it just explodes. And this is an experiment which maybe could not work out too well, which is okay because mason jars are all different and there's no approximate level of hydrogen peroxide that you need to use per se. It's kind of just guessing. So that should be good. We do know a tablespoon of yeast. Let's get ready because this kind of escalates quickly. So we basically just poured the hydrogen peroxide in the mason jar. We'll now introduce the yeast directly into this. Will then shake it and introduce chemical reactions. We have to get everything like ready quickly. Give it a bit of a shake. Hopefully that's enough. Make sure this is sealed. We don't want any sort of bad things happening. I can already like feel the heat. So try lighting the match now. Come on. Okay, take two. You might not have added enough. Let's try one more time. You do hear sparks. Okay, there we go. Ooh, it fizzled. Sometimes that happens. Okay, folks, we'll give it one more shot. Apologize for this. Maybe shake it up a bit more, perhaps. Just one more try. Let's try that. One more shot. Come on. Okay, well, unfortunately, This one is going to be a bit of a dud, the first one, but it is, as I said, a bit difficult to measure, especially when you only have kind of taller mason jars. You'd have to use a lot of hydrogen peroxide. This is also only 3%, which is not as potent as 30, but let's do a theoretical kind of take. Let's say you did see some sparks come out of it, so it's I guess you could say a small reaction. Imagine those little sparks that came out of it as a much bigger, like, fiery explosion. We can kind of still talk about that and kind of what goes behind it. So when we mix this together with the ZD, let's explain it a bit. So this goes with catalyst and decomposition. Catalyst is kind of a remarkable enzyme that accelerates the breakdown of hydrogen peroxide, which is a process that would otherwise be too slow to observe. This is why this experiment helps with this. This acceleration of a chemical reaction by a substance, which remains unchanged, is known as catalysts. The yeast, which we put in, is rich in catalase, which plays a crucial role of the catalyst, breaking down the hydrogen peroxide we put in into two simpler substances, that being water and oxygen gas. This process of a single compound breaks down into two or more simple products called decomposition. So the release of the oxygen gas with this, as the decomposition proceeds, oxygen gas is released. You can observe this. We did see the bubbling and foam. Even though the ZD explosion wasn't perfect, we did see a good amount of this effect at least. So with the release of oxygen gas, as the decomposition proceeds, oxygen gas is released, and that was the foaming in the mason jar when we shook it around. The oxygen gas is crucial for the next part, which came with the experiment, the combustion of the pasta, with this few sparks that we saw. But again, it should usually be a much fiery display. We would probably just have to add either a lot more hydrogen peroxide or more potent hydrogen peroxide. But we can talk about the combustion of pasta regardless. So even we can talk, like, why does it even spark per se? Like, why is it so energetically charged with this? This is tying into combustion. So combustion is a high temperature exothermic reaction between a fuel and an oxidant. In this case, the fuel is our ZD pasta, which is primarily composed of carbohydrates, complex molecules which are rich in carbon and hydrogen. The oxygen gas released from the decomposition of hydrogen peroxide acts as the oxidant here. When we introduce a flame via the match, it provided the activation energy needed for combustion to occur. Not fully, unfortunately, but you saw a bit of it. The oxygen reacts with the carbon and hydrogen in the pasta, forming carbon dioxide and water, and releasing a significant amount of energy in the form of heat and light. And that was the sparks you could see. It did wrap around with some fire and ashes to the side, so you can see that it does affect with kind of the chemicals down here. Just we didn't get enough of a potent mixture of it. So how can this intertwine with like chemistry and even physics, which I find interesting? We can observe in this regardless. It's quite the interplay of both of these. Like, the chemistry of catalysts and decomposition leads to the physical process of combustion, of course, and it can be like an illustration of how different branches of science are interconnected, and how a series of reactions can lead to a awesome display of energy releases when done correctly. So yeah, although again this didn't go perfectly to plan, you could see most of it still go into fruition. We got the foaming mixtures. We did get some sparks. Unfortunately, I think we just didn't have the hydrogen peroxide mass or potency of it. Maybe if we used a 30%, we would have gotten it. But regardless, I hope I was able to help with explaining a bit of the chemistry and a little bit even of the physics behind this. And if you do this for yourself, be careful. Hydrogen peroxide is dangerous, but also cool. And until next time, thank you for watching this.